grows lighter as it ascends. The atmosphere does, in fact, weigh down upon land at the level of the sea as much as if a 15-pound weight were put upon every square inch of land. This little piece of linen paper which I am holding up measures exactly 1 square inch, and as it lies on the table, it is bearing a weight of 15 pounds on its surface. But how then comes it that I can lift it so easily? Why am I not conscious of the weight? To understand this, you must give all your attention, for it is important and at first not very easy to grasp. You must remember in the first place that the air is heavy because it is attracted to the earth, and in the second place that since air is elastic, all the atoms of it are pushing upwards against this gravitation. And so, at any point in air, as for instance the place where the paper now is as I hold it up, I feel no pressure, because exactly as much gravitation is pulling the air down, so much elasticity is resisting and pushing it up. So the pressure is equal upwards, downwards, and on all sides, and I can move the paper with equal ease any way. Even if I lay the paper on the table, this is still true, because there is always some air under it. If, however, I could get the air quite away from one side of the paper, then the pressure on the other side would show itself. I can do this by simply wetting the paper and letting it fall on the table, and the water will prevent any air from getting under it. Now, see, if I try to lift it by the thread in the middle, I have great difficulty, because the whole 15 pounds weight of the atmosphere is pressing it down. A still better way of making the experiment is with a piece of leather, such as the boys often amuse themselves with in the streets. This piece of leather has been well soaked. I drop it on the floor, and see, it requires all my strength to pull it up. I now drop it on this stone weight, and so heavily is it pressed down upon it by the atmosphere that I can lift the weight without its breaking away from it. Have you ever tried to pick limpets off a rock? If so, you know how tight they cling. The limpet clings to the rock just in the same way as this leather does to the stone. The little animal exhausts the air inside its shell, and then it is pressed against the rock by the whole weight of the air above. Perhaps you will wonder how it is that if we have a weight of 15 pounds pressing on every square inch of our bodies, it does not crush us. And indeed, it amounts on the whole to a weight of about 15 tons upon the body of a grown man. It would crush us if it were not that there are gases and fluids inside our bodies, which press outwards and balance the weight, so we do not feel it at all. This is why Mr. Glacier's veins swelled as he grew giddy in thin air. The gases and fluids inside his body were pressing outwards as much as when he was below, but the air outside did not press so heavily, and so all the natural condition of his body was disturbed. I hope we now realize how heavily the air presses down upon our earth, but it is equally necessary to understand how, being elastic, it also presses upwards, and we can prove this by a simple experiment. I fill this tumbler with water, and, keeping a piece of card firmly pressed against it, I turn the whole upside down. When I now take my hand away, you would naturally expect the card to fall and the water to be spilled. But no, the card remains as if glued to the tumbler, kept there entirely by the air pressing upwards against it. And now we are almost prepared to understand how we can weigh the invisible air. One more experiment first. I have here what is called a U-tube, because it is shaped like a large U. I pour some water in it till it is about half full, and you will notice that the water stands at the same height in both arms of the tube, because the air presses on both surfaces alike. Putting my thumb on one end, I tilt the tube carefully, so as to make the water run up to the end of one arm, and then turn it back again. But the water does not now return to its even position. It remains up in the arm on which my thumb rests. Why is this? Because my thumb keeps back the air from pressing at that end, and the whole weight of the atmosphere rests on the water at sea. And so we learn that not only has the atmosphere real weight, but we can see the effects of this weight by making it balance a column of water or any other liquid. In the case of the wetted leather, we felt the weight of the air. Here we see its effects. Now, when we wish to see the weight of the air, we consult a barometer, which works really just the same way as the water in this tube. An ordinary upright barometer is simply a straight tube of glass filled with mercury or quicksilver and turned upside down in a small cup of mercury. The tube is a little more than 30 inches long, and though it is quite full of mercury before it is turned up, yet directly it stands in the cup the mercury falls, till there is a height of about 30 inches between the surface of the mercury in the cup and that of the mercury in the tube. As it falls, it leaves an empty space above the mercury, which is called a vacuum, because it has no air in it. Now, the mercury is under the same conditions as the water was in the U-tube. There is no pressure upon it in the tube, while there is a pressure of 15 pounds upon it in the bowl, and therefore it remains held up in the tube. But why will it not remain more than 30 inches high in the tube? You must remember it is only kept up in the tube at all by the air which presses on the mercury in the cup. And that column of mercury now balances the pressure of the air outside and presses down on the mercury in the cup at its mouth just as much as the air does on the rest. So this cup and tube act exactly like a pair of scales. The air outside is the thing to be weighed at one end as it presses on the mercury. The column answers to the leaden weight at the other end, which tells you how heavy the air is. Now, if the bore of this tube is made an inch square, then the 30 inches of mercury in it weigh exactly 15 pounds. And so we know that the weight of the air is 15 pounds upon every square inch. But if the bore of the tube is only half a square inch, and therefore the 30 inches of mercury only weigh 7.5 pounds instead of 15 pounds, the pressure of the atmosphere will also be halved, because it will only act upon half a square inch of that surface, and for this reason it will make no difference to the height of the mercury whether the tube be broad or narrow. In the ordinary upright barometer, the cup of mercury in which the tube stands is hidden inside the round pieces of wood, and just at the bottom of this round is a small hole through which the air gets to the cup. But now, suppose the atmosphere grows lighter, as it does when it has much damp in it. The barometer will show this at once, because there will be less weight on the mercury in the cup. Therefore, it will not keep the mercury pushed so high up in the tube. In other words, the mercury